Everyone. Thanks for joining us for the second lecture, first real lecture of the virtual seminar or virtual PhD course on environmental economics. We're delighted to have Ben Olken from MIT and Seema Jayachandran from Princeton, who are going to be talking to us about the economics of conservation. As last week, we have a Q&A panel available for you, but please do remember that this is a place to post questions about the lecture and course content. As last week, Allegra will be helping to answer some of those as we go, and we're also joined by Aaron Berman, who is a PhD student at MIT, who will also be helping out with those live, but will be leading the Q&A session at the end. So as a reminder, after the hour of content, you'll have a chance to further engage for 20 to 30 minutes with Aaron. So the other admin point before we kick off is if you're interested in being live as a panelist and having your video on during the lecture, please put up your hand and we'll select 20 of you. And other than that, I think we're ready to start. I believe Ben is going to kick us off. Let me pass it over to you.
Terrific. Thank you very much. Let me share my slides. So, Kelsey, slides are working? Yes? Okay, great.
Looks good.
Well, thanks very much, everyone. I'm delighted to be here and to talk about political economy and conservation. So actually, and conservation more generally. So just by way of background, today's topic is conservation in low and middle income countries with a sort of a focus on the forest sector. And just to set up kind of what the basic issue is, like why are we even thinking about this? The basic economic issue that is sort of behind all this is the concept of externalities. So what does that mean? That means there's a wedge between the private value of something and the social value of something. So for example, in the case of forests, private landowners might like to deforest. They might gain value from the timber and the value from the land, but forests have social benefits that those landowners take into account. For example, they have vast quantities of stored carbon. They're important for biodiversity. They're important for watershed protection and so on and so forth. And so there's a wedge between kind of what the private landowners would do just for themselves and what society might like them to do, taking all those other things into account. And so what government does is government likes to, in a case where you have an externality, government policy should come in to intervene to correct the externality through regulation or prices or things of that nature. So that's kind of the basic overall framework. So what we want to talk about today is sort of two challenges to doing so. Two challenges to say, why don't we just sort of solve that problem? Why isn't the externality being corrected? And how can we potentially move forward to do so? So I'm going to start off by talking about political economy challenges, and in particular, the challenge is that sort of in a lot of the sort of low and middle income countries that we're focusing on, there's a wedge between kind of what maybe the de jure kind of laws say that should be happening, that might internalize the social benefits, and what's happening in practice. So I'm going to both sort of say, what do we know about the extent of that wedge, and what is actually driving that distinction between kind of de jure and de facto, and what are the political economy factors? So I'll give you a few different examples along those lines. And then in the second half of the lecture, what Seema Jayachandran is going to talk about is poverty as a barrier to conservation. So in particular, in these low and middle income countries, what does the fact that people are poor imply for conservation levels and policies? And should we be paying people to conserve, and how should that work? Okay, so that's kind of the plan for our hour together today. All right, so the first thing I want to talk about is de jure versus de facto, and this is from a paper of mine joint with Robin Burgess and Francesco Costa about national borders in the Amazon. And so, as many of you know, the Amazon rainforest is the largest rainforest, largest in the world. It's the world's largest tropical forest, covers more than 2 million square miles. This is the size of the U.S. west of the Mississippi River. It's larger than the European Union. This is really, really large and important tropical forest. And over the sort of the first 2 decades of this century, 55% of global forest loss was coming from the Brazilian Amazon, according to the FAO. And I think what I want to say from the perspective of this lecture is, deforestation in Brazil has been limited for several times, for a long time, but the penalties for deforestation were relatively weak. For example, deforestation in the Amazon outside of protected areas was an infraction, not a felony, until 2005. So like it was not allowed, or it was limited in terms of how much you could do, but sort of the penalties for it were relatively weak. And so likewise, private properties in the Amazon were required to have 80% forest cover, but again, this was an infraction. It wasn't sort of really seriously enforced until kind of the mid 2000s. Starting in 2005, Brazil increased its enforcement of these policies, strengthening fines, increasing enforcement in a variety of ways, including using satellite data and a variety of other things. And so what we want to ask in this paper is sort of, on net, first of all, what is the effect of kind of the overall Brazilian policy relative to other policies? How much of the deforestation level is coming from the degree to which the government is intervening to correct this wedge, right? How much is sort of, and versus how much of it is just sort of like there's underlying kind of forces that are leading people to deforest? How much of the distinction is coming from what the government is doing? And secondly, like as the government changes kind of its overall enforcement policy, as it sort of ratchets up the degree to which it's going to increase enforcement, is that sort of doing a better job of maintaining that of enforcing kind of that wedge that the government's trying to do? Okay. So, and what we're going to do in this paper is we're going to study this question by looking what happens at the international border of Brazil. And so this is also, I think, from a more general kind of perspective, a useful example of if you haven't seen it before, what's called a regression discontinuity design. So I want to spend a couple of slides on sort of how does that work and what are the implications for that. Okay, so in particular, the idea of the paper is to compare deforestation right across both sides of the border. So for example, we're going to look at what happens, as the Brazilian border, in Brazil side, right up to the Bolivian border, and compare that with what's happening just on the sort of Bolivian side. And the idea is that like across, if there's lots of differences in sort of profitability, soil quality, forest, etc. But if we zoom in really close to the border, those other aspects like profitability, soil, etc., those things should be constant. Okay, so if we compare deforestation on both sides of the border, zooming really close to the border, we're going to capture what's the effect of being in Brazil. Okay, and the level differences at the start of our period are going to say what was the difference of being in Brazil up to that point, and then we can actually look year over year as to what happens across that border to measure sort of the change or tightening up in enforcement. And so by zooming in on the border, this is called a border regression discontinuity design. So how does that work? Just formally, suppose that the land use in a given region is given by the land, we'll call this LD, where D is going to index kind of distance to the border. G is kind of a government policy. That's what we want to kind of mention. And epsilon D is like everything else that determines kind of the profitability of deforesting in that area. Okay, basically everything else that determines land use. And so the idea is, the profitability of deforesting in this area, that's going to be distributed kind of in some complicated way across space. But as we zoom in on the border, as we approach, distance, say from the right or distance from the left, I guess that's from the left, that's from the right, those general factors should become more and more similar. And what we're going to be left with is just the differences due to kind of the government policy. So that's what we're going to do. And in particular, so if this is the idea, we're going to estimate an equation where we're going to say, what is the outcome variable? For example, annual forest loss measured from satellite data. We're going to regress this on sort of whether you're in Brazil or not. We're going to control kind of flexibly for this distance to the border. And what's going to be left is sort of, and then there's these other epsilons. And the idea is that as we get close enough to the border, other factors like land are going to be pretty similar. And so we're going to be left with kind of the effect of being in Brazil. And I'll show you graphically what this means. Okay. And as I said, this is a regression discontinuity design. It's a very general design for a wide variety of empirical settings. Okay, to analyze this, we're going to use satellite data. So there's a very useful satellite data set that was created by Matthew Hansen at Maryland and his co-authors, which was published in Science in 2013 and is updated regularly. This data set basically tells you annual deforestation rates every year at the 30-meter level, which they compute based on Landsat. And this is a global database. It's available for the entire world. It's available for free. You can go download it. And so it's become a really powerful data set for analyzing deforestation at the micro level. Actually, we have so much data, we're actually going This is really, really detailed, 30 meter squares. We're actually going to aggregate it to 120 meter squares for computational simplicity, and you'll just see in the images how much data we're talking about. Okay, so just to be clear, this is an example of the border. This is a picture I found from between Bolivia and the state of Mato Grosso in Brazil. You can see it's kind of pretty porous. And in particular, this gives you a sense of kind of what we're looking for, right? So this is Brazil, this is Bolivia, and this river here is the border. Okay, so that's the idea of what we're trying to sort of capture in the data. Here's another example. Like this is from Google Earth. This is just a straight line. It's not just natural boundaries. This is a straight line. And I don't know if Google Earth got this exactly right, but you can certainly see something very different is happening on this side of the line compared to this side of the line. So our question is to say, can we do this kind of in aggregate across the entire border? So this is the Brazilian border. You can see sort of the Amazon here. This area over here is called the so-called arc of deforestation. Sort of as deforestation is kind of moving in from sort of the southeast into the Amazon. And what we're going to do is we're going to look across this entire border, this huge border, and we're going to zoom in really, really, really close, because the identification assumption that I mentioned before is that as you get really close to the border, the differences really are just due to which country you're in. Okay, so for example, we're going to take this entire border, but we're going to zoom in on this little red box here, and it's going to look like this, for example. Okay, and even here, this gives you a sense. This is 17 kilometers. So that's what our whole analysis is going to basically zoom in to sort of, about 2017, some small number of kilometers on both sides of the border. And again, you can see in this example, the differences are pretty stark, right? This is this is deforested, this is still forest. This is kind of this arbitrary straight line border. And you can see like the deforestation patterns are really following kind of the border. There's really something different happening on the Brazilian side. Okay. So when we do this in regression form, this tells you, or across the data, this is telling you the percentage of forest cover in the year 2000 across the entire Brazilian border. And this is the distance from the border. Actually, here I have 100 kilometers on either side plotted. And what you can see is that, in general, there's a lot more forest on the non-Brazilian side compared to the Brazilian side. The percent of forest cover moves from, there's still a lot of forest in the Amazon, so it moves from sort of in the 80s to in the 90s. But you can see it drops off totally precipitously right when you cross the border in Brazil. So this is really close, just a kilometer on either side, you see these massive differences. So clearly something is going on the Brazilian side that's leading to more deforestation. The second thing is, this is actually just what's happening in the year 2000. We can then do this kind of again and again, year by year. So here I was actually broken it into sort of 3 periods. This is sort of the first, this is annual deforestation in the first 5 years, 2001, 2005. Again, you can see there's much more deforestation year by year, almost 4 times higher on the Brazilian side of the border compared to the non-Brazilian side of the border. Then what happened, if you remember what I was saying at the beginning, there was sort of a bunch of crackdowns in Brazil or enhanced anti-forest policy in Brazil in the mid-2000s. So what you can then see is actually then that falls off. Oops, sorry. Here. If you look sort of in the period 2006, 2013, that falls off dramatically, and you see much less differences. So when Brazil sort of enhances their enforcement, those deforestation rates fall right back down. The third period is sort of Brazil then sort of relaxed with that policy, and it came right back up again. Okay, so clearly, I think, what are we taking? And this basically shows you, the next graph shows you sort of, oops, sorry. Proceeding here. Yeah, year by year. So each of these dots here is sort of the difference in that discontinuity from year to year. And you can see, year by year, there was sort of a lot of excess deforestation in Brazil through this period. As they sort of increased enforcement, it fell down dramatically, almost to 0 on average for this period. And then as the enforcement kind of relaxed, it came back up again on the Brazilian side. So what's sort of the point? The point here, I think, is that what this paper is saying is there's something going on. Sorry, I don't know why it's not going forward. Okay, there's something going on in state policy that's determining the wedge between, what I was calling as de jure versus de facto conservation policy. So something is happening where, the Brazilian government is clearly both having their policy is having a really important role in the level of deforestation in the Amazon. It's not kind of these, broader forces necessarily. It's something that's happening in Brazil. And number two, it responds to sort of the changes in enforcement. So when Brazil tightens up its enforcement policy, that wedge, sort of shrinks and the difference becomes more stable. When it relaxes, it comes back up again. So there's something going on in kind of the political economy of state policy that's determining the overall level of conservation. So the next question is, well, what exactly? And there's lots of different factors, and sort of what's leading Brazil. I'm sorry, I keep going backwards. What's leading Brazil to change its policy, and more generally, what are the political economy factors that sort of influence kind of this wedge? And so this is really active research. There's lots of different understanding of why it might sort of relax or not relax over time. Like why is it changing from time to time? But I'm going to explore two things today. One thing I'm going to talk about is bureaucratic incentives. And in particular, I'm going to talk about another project that we did looking at decentralization and competition between political actors and how that could sort of lead to changes in the level of enforcement. And the second thing, I'm really sorry about this. I don't know why it's doing this. And the second thing is I'm going to look at political incentives or electoral cycles in deforestation. So one is kind of a bureaucratic incentives and one is going to explore political incentives. And that's not meant to be exhaustive. This is not the only things that's driving kind of these changes over time, but I think it's something that is important and is important to sort of understand. Okay. So the first thing I'm going to talk about of these things is a bureaucratic channel, and that's through decentralization in Indonesia. And this is a paper of mine with Robin Burgess, who's here, Matt Hansen, Peter Potapov, and Stephanie Sieber. So here we're going to switch to a second area where there's a second sort of country which has a huge amount of tropical forest, which is Indonesia. So in Indonesia, as in many countries, the national government sets kind of the official de jure forest rules, but then somebody has to actually enforce those rules. Okay, and those are going to be and local officials are going to be the ones who are actually doing the enforcement. Okay, so for in Indonesia, for example, the central government still retains control over the final permit issuance in negotiation kind of with local districts. It also controls kind of what the conservation zones are. But it's district forest officials who are the ones who are sort of located in these various districts, who are the ones who are responsible for sort of administering this policy, helping come up with what are kind of cutting plans and legal zones, enforcing things throughout. And so these district governments are playing a key role. So the idea that we explore in this paper is the idea that there could be competition between districts. So, in the model, we say that each district head gets to sell, quote, sell permits in exchange for bribes. And there have been examples actually where several local officials have in fact been investigated by the Indonesian Anti-Corruption Authority for this kind of activity. But it doesn't have to be a bribe. It could actually just be in general they get some local returns from deforestation. Could be, for example, they just like having more economic business in their area. But this is the model. It works like this. There's a downward sloping demand curve. So the more permits in the model that he or she sells, the lower the price is going to be per permit. But the idea is that district heads compete against one another in the market for these illicit permits. So if there's one district head in an area, he or she is the monopolist, right? And they're going to charge a high price, issue few permits, and there's going to be less deforestation. But what happens if districts split? Then there's going to be many different district heads in an area. There could be low prices, lots of permits, and potentially more deforestation. So the question of this paper is to understand when Indonesia experienced more decentralization and there was more of these different district officials, how did that change the amount of deforestation? Okay. So, and the way we're going to examine this is we're going to use the fact that there was a 1999 law in Indonesia that decentralized many domestic functions to districts. In particular, and then after that, there was sort of a rampant amount of district splitting. So in 1998, there were 292 districts in Indonesia. In 2008, there were 483 districts. And in the forest islands that we're going to focus on, this went from 146 districts to 311 districts. And they split for a variety of reasons, kind of more local control, kind of the central formula that allocated block grants to districts had some reasons for them to split. There's a variety of reasons for that. But the key point in our perspective is, the total amount of forest did not change, right? What changed is that it used to be that, you would control kind of the whole forest in one particular area. And now that got sort of subdivided, and one district controls this part and the other district controls this part. And that's what we sort of want to study. How does increasing decentralization change the level of deforestation, potentially through this lens of increased competition between districts? Okay, I'm sorry. Why this keeps happening? Okay. So this is going to be what's called a difference in difference study. So the idea is, here are all the different provinces in Indonesia that we're going to examine. These are, and this just shows you the number of new districts that were introduced in these provinces because of this district splitting over time. And what you can see is that, there's a lot of new districts, right, overall, but they happen in different places in different times. For example, in the province of South Sumatra, there were 3 new districts created. It started with 7 districts. They added 3 districts in 2001, 1 district in 2002, 3 districts in 2003. In the province of Bengkulu, which is actually, nearby, they started out with 4 districts, but they didn't add their first district until 2003. Then they sort of waited a bit. Here, for example, in central Kalimantan, they added 8 districts in 2002, and that was it. Here in North Sulawesi, it was 3 and 1 here, 3 in 2003, 4 in 2007, and so on and so forth. So what you can see is that while in general Indonesia was adding more districts, when those happened in different provinces, happened in different times. And that's what we're going to use for empirical identification in this paper. Okay. So in particular, what we're going to do is we're going to look at the province level. So we're going to look at those provinces I just showed you. We're going to look at and we're going to say, what's the relationship between the rate of deforestation and the number of districts in the province. Okay, and given that there are many zeros, we're going to use count data, and we're going to a count model, which is a Poisson model. I don't think we need to go into a lot of details on that, but the key idea is we're going to look at the number of pixels that are deforested. In this one, we're going to use different data sets that I'll talk about in a minute. And we're going to look at the relationship between that and the number of districts in the province. And we're going to put in what are called fixed effects for provinces and for time, or island times time. So what does that mean? It means we're going to control kind of arbitrarily, allow the regression model to control arbitrarily for the number of the fact that average deforestation rate might be different in different provinces. We're going to control arbitrarily for the fact that some years may have been higher or lower deforestation years, depending on, say, market prices or conditions or whatever. And we're going to look at sort of, once we control for what's happening in general in the province and what's happening in general year by year, are those provinces that had more decentralization in a given point in time, does that lead to more deforestation, sort of taking all those time effects and province effects into account? Okay, so that's the basic idea. In this data, this paper was actually written before our collaborator Matt Hansen released that science data set that I mentioned. So actually, it's a different data set that he developed that we worked on with him. If we were doing it today, we would probably do this using the Hansen data. And so in this one, actually, it's slightly coarser. It's 250 meters, but still, that's pretty fine grained. And in particular, since we have pixel level data, we can overlay it with GIS information on Indonesia's 4 fixed production forest zones: production, conversion, conservation, and protection, which is going to allow us to look at sort of what's happening in more detail. So this just gives you a picture. I think Robin Burgess may have showed this actually last week. This just shows you kind of an example of kind of what deforestation looks like. We're zooming in on an area in Riau in central Sumatra over here. This is the beginning of our period in 2001. The green is forested, the yellow is deforested, the red is the change. And you can see sort of as we sort of go forward, in time, you can sort of see the deforestation picking up. So we want to ask whether or not the changes in deforestation here are related to the changes in decentralization. And the answer is they are. So in particular, if we run in this regression, we find that when there are more districts in a province, in that year in particular, there's about 4% more deforestation. Overall, if we take into account the fact that it may take some time for these new districts to get set up and get going, if we include some lags, on net, it increases by 8%. Okay, so more districts, more decentralization is leading to more deforestation. And one thing that's I think pretty interesting is this is not just happening in kind of the production zone. It's not just happening through the sort of the official sanctioned deforestation. It's happening kind of equally across all of Indonesia. So it seems like there's something going on where, when there are more districts, the sort of the ability of the central government to sort of regulate exactly how much deforestation is happening seems to become a little bit weaker. So that's kind of the main point. And it's also the other thing is we actually also have some data on wood prices in the area, and we find actually that wood prices are falling by between 1.7 and 3.6% in these areas. And we sort of go through in the paper that's consistent with what some economic theory based on the simple model might predict. Okay, but stepping back for a minute, what's kind of the point that I want you to take away from this is, there's something going on in sort of the bureaucracy of administering the forest policy, which is saying when there are more districts in the province, sort of the somehow that leads to sort of a bigger wedge and sort of less ability of the central government to sort of enforce kind of the amount of deforestation that is on the books. Okay. Second thing I want to look at is political cycles. Okay, so this is another paper with my co-authors Balboni, Burgess, Heil, and Old. And here we want to look at sort of the political economy of and local election cycles. So, there are lots of reasons why there could be a relationship between electoral cycles and deforestation. Could be, for example, that politicians need campaign contributions. Maybe they allow more deforestation in the years before because they need campaign contributions. It could just be simply that voters dislike deforestation, especially when linked to forest fires. And maybe voters are just more attuned to this during election years, or politicians are more responsive during election years. So maybe politicians are sort of saying, look, we're going to clamp down this forest policy now when voters are really paying attention to it, and potentially not in other years. But this sort of an empirical question is the political cycle also leading to sort of changes in sort of the degree to which this forest policy is being enforced. And so we're going to examine this in Indonesia again. And we're going to use the fact that district heads are on 5-year terms, but at different terms in different districts. Okay, so in particular, just basically for historical reasons, actually that's no longer true. They've now synchronized, but in the period that we're studying, they were on different sort of electoral cycles. So we can use the fact, again, we can do the same thing. We can control for sort of time effects and district effects, and we can say controlling for sort of the overall deforestation level in the district and the overall deforestation in a given year. If you happen to be in an election year, how does that change kind of the deforestation level? And we can look kind of across kind of the 5-year cycle. And for this one, we'll use the more updated Hansen data. We'll also have data on forest fires as well, which we developed from another paper with Carl Balboni and Robin Burgess, which I don't have time to talk about today. But we want to sort of look at sort of what the relationship is with electoral cycles. And the answer is, you can see we have 3 different measures. So this is actually more focused on fires. This is sort of forest fire ignitions, total area sort of burn in the forest, and what we called here slash and burn, which is basically you deforest and then you sort of immediately clear it using forest fire. So this is a combination of deforestation and fires, and this is just forest fires. And what you can see is that sort of in all 3 of these measures, you see a dip in kind of this kind of activity right in the election years. So it looks like something is happening where the attention to sort of the amount of deforestation is increasing in election years relative to all other years. So that says that there's something about the political cycle that's also kind of influencing the degree to which kind of the state is regulating kind of this activity. Okay, and there's nothing, as far as to the best of my knowledge, there's nothing in the law that's changing. It's all sort of changing kind of the enforcement. Okay, And you actually here we divide this again into production forest and conservation forest. Here we see this all in the production forest, and basically not much at all going on in the protected forest. So here actually it seems like it's something about the interaction between the state and sort of the people that are acting in the production forest that's driving kind of these changes. So to sum up, what does this paper say? There's a dip in deforestation in election years. There's a substantial rise in deforestation just after elections. And that suggests that there's something happening, that the enforcement is kind of happening when it's politically salient more so than in other years. And so that says that there's also a role for the political process in determining kind of the level of enforcement. So stepping back, what have I sort of tried to convey? Conservation requires government action because of the gap between the private and the public incentives. But there's a gap between kind of the de jure rule saying don't do this and the degree to which people are responding. Okay, and that comes from both. That can come from the sort of the level of fine, the level of enforcement on the books, like maybe changing fines, and it can also just come from sort of the degree to which the state is involved in enforcement. And so, what we showed in the Brazil paper was that the overall deforestation rates are clearly different. They're responsive to state policy, and they are highly sensitive to those changes in state policy and enforcement as identified by looking across the border. And then through the Indonesian paper, we explored sort of both two different factors that sort of lead to changes in sort of the degree to which those policies are being enforced. One bureaucratic change through decentralization of the bureaucracy, and one political change by looking at electoral cycles. So I will now turn it over to Seema, who's going to talk about sort of, in some sense, what is the implication with poverty and what can be effective to do this. So Seema, why don't you take it away from here?
Great, thanks. I'll share my screen when you. Okay, great. All right, hello everyone. I'm going to pick up where Ben left off and talk about another challenge to conservation that's stronger in low and middle income countries. And so that I'm mostly going to talk about, and depending on how I do on time, maybe exclusively talk about how poverty, lack of economic development affect the optimal policy for promoting conservation. I'm using optimal in a loose sense, not maybe the way an economic theorist would. And then if time permits, I'll say a little bit about how poverty and economic development affect just the overall level of conservation. Okay. So the policy objective, as Ben was saying, of sort of charging a price in some general way, the policy objective is to raise the private cost of environmental degradation, make it more expensive from the point of view of the person who would be degrading nature. And so one possible approach is command and control regulation, telling people they're not allowed to do that and protecting it, maybe imposing some financial fine or some other punishment. And so what Ben talked about were the governance challenges, that what de facto happens might be different than what the de jure goal was because of corruption or limited state capacity and the like. What I'm going to talk about is, or maybe what motivates different approaches than command and control or taxes, is that even if we were able to enforce a command and control policy, doing that might further impoverish poor people. Because if you're telling people they can't do an activity, and that was an activity that was helping them economically, then depriving them of that opportunity is good for the environment, but it's hurting their economic well-being. And in many settings, that's okay. If it was a high profit firm that was going to have to stop doing some polluting activity, install some scrubbers, we might be okay about that in terms of the distributional consequences. But when we're thinking about low and middle income countries and maybe smaller firms or individuals and households, that's undesirable. Okay, so a kind of very logical, obvious way to get some of the benefits of fining people for an activity if they degrade, but without the poverty consequences, is to turn that fine or that stick into a carrot and say, we're going to reward you if you avoid that polluting behavior or that degradation of the environment. And so this idea of financial rewards for conservation or any environmental, pro-environment activity is called payments for ecosystem services, or PES. And so it's a payment to an individual or a group in exchange for some specified pro-environment behavior. And so note that it's voluntary. If that payment level, you're not banned from doing an activity. So if that payment level is not attractive to you, if you can make more money continuing to degrade, you can keep doing that. And so the fact that it's voluntary and you only do it if it's attractive to you means that you shouldn't be worse off financially. So you take it up if it's making you better off. This is also, compared to command and control, this is also has a nice market-based property that if we want to achieve a certain amount of conservation, there might be some people who it's efficient for them to keep degrading. Maybe they have amazingly productive agricultural land, they're fantastic farmers, they can produce a lot of food for the community. So they'll say, this isn't attractive, I'm going to continue polluting. Somebody else who's not as productive, they'll take the payment. And that's exactly the allocation of where we should be taxing or hurting the environment, where we shouldn't. This market mechanism takes that into account. Okay, so an important point that I'll come back to later is that the goal of PES, it's not to reduce poverty, it's to protect the environment without exacerbating poverty. Okay, so I'm going to talk about a project of mine with many collaborators in Uganda that was aiming to reduce deforestation through PES. This is a context in which a lot of the natural forest was owned by households, agricultural households, quite poor households. They owned forests and they would clear it for two broad purposes. One is they wanted to use the land usually for subsistence farming, growing cassava or beans or other food to feed their family. A few people were growing cash crops, and those would be the examples of people who might say, no thank you to PES. The other reason to cut is because those trees themselves are valuable. If you have a nice, tall, straight tree, you can sell it for lumber. What's very common in East Africa is to use trees for charcoal, which is then used for heating and cooking in urban, rural too, but also in urban Africa. And I guess importantly, the amount that people make from this is going to be very low if we thought about it in US dollars, or if we later think about it relative to the benefits of keeping that forest intact from a conservation point of view, biodiversity. But we wouldn't want to deprive people of this money that they're using to feed their family or send their kids to school. Okay, so it seems quite logical that this is should be a good idea. It shouldn't make people worse off, and if we can find ways to protect the environment, that's great. I think there are two reasons that this might not be that effective in practice. One is what the literature calls, lack of additionality, where additionality means, is about the actual effect of the program. And the reason that's not obvious that a lot of the payments will go towards additional forest cover is, most people aren't cutting down their forest every year. If that were the case, we wouldn't have any forest. So lots of people were going to keep their forest intact anyway, or they were going to cut a little bit. And the challenge is that when you have a program like this, the policymaker doesn't know what someone was going to do. So it's hard to target, to the people who were going to cut. So you offer this program to everyone, and many of the payments might be inframarginal, or you're paying people, they meet the requirements, they keep their forest intact, but they would have kept it intact anyway. So that's making payments, but no conservation benefit. And so that's a challenge if you're just if you're trying to attribute the benefits of the program to, look how little deforestation there was among people who signed up. You really want to know what the counterfactual is. And the other challenge is that people might comply with the program on their land, they don't deforest, but they just shift their deforestation elsewhere. And there are, different scales at which you can think about this. Maybe I comply and don't deforest on my land, and I just ask my neighbor, can I use some of your land for my agriculture because and I'll share some of my money with you. So that's called leakage. It's just a shifting of deforestation elsewhere. You can also think about leakage at a broader market scale of a general equilibrium effect. If all of Uganda had a much less deforestation because of PES, what's going to happen? There's less charcoal available in Kampala. So some of that, we hope, is that people will shift to other forms of fuel. They'll be better about conserving how much fuel they use, get a fuel efficient stove. But we might think, in neighboring countries, that's going to, the price of charcoal is going to go up and some new supply could come in. And so markets, these general equilibrium effects are also a form of leakage. Okay, so in a study with collaborators, we did a randomized trial across 121 villages in Western Uganda, where we offered a PES program. We introduced a PES program in 60 of the villages. And so how is this helping with the challenges of measuring leakage and additionality? I think additionality, it's much clearer cut. We now know the counterfactual. This is the beauty of randomized trials. We're going to know how much deforestation was there absent PES. We have the treatment villages with PES. We can compare them and know whether the lack of deforestation we see in the treatment villages is because of PES or just what people would have done anyway. With leakage, an RCT is not going to give you any special purchase on solving leakage or addressing it, but because we're collecting data and we have detailed satellite imagery, we can try to measure the extent of local leakage. Is deforestation shifting within the village? Is it shifting to neighboring villages? Is it shifting to government reserves? I can tell you in brief now, we don't see any evidence of that leakage. In terms of the GE effects I mentioned, in this case, a study of this scale just isn't well positioned to say how much, if you scaled this up countrywide, what would this have done to the price of charcoal and consumption and deforestation in neighboring countries. The reducing deforestation in 60 villages or even 121 villages is a drop in the bucket in the market in Kampala and Entebbe, so you won't be able to pick that up. Okay, so just some details on this program. It was a PES program that was run for 2 years by a local NGO called Chimp Trust, and households that owned primary forests, they were offered money if they kept their forest intact. So it was 70,000 Ugandan shillings per hectare, which was about $28 at the time. And so a typical landowner had 2 hectares of forest, so they could earn $56 a year, or over the course of the 2-year program, $112. So that's a lot of money in a poor area, but not a lot if we were thinking about funding this from wealthier countries. And in this case, it was funded by the United Nations Environment Program. So for the actual deciding who complied and earned their payment, Chimp Trust had staff on the ground going and checking. And then there was a provision that you had to enroll all of your forest. And if you didn't comply 1 year, you weren't eligible in the next year. And this is so you can't just sort of shift your deforestation very easily by enrolling part of it and deforesting on the left out part, or deforesting 1 year and then saying, doing 2 years worth of deforestation in the first year and then entering. Okay, so for our outcome as researchers, we didn't use boots on the ground, we used satellite imagery. And so we purchased commercial satellite imagery. Today, 10 years later, you can get this resolution of satellite imagery for free, which is, just amazing progress for studying these conservation questions. And so, you could see with your eye, you could see every tree. And so we obviously don't do this by hand. We use a computer algorithm to code up pixels as tree covered or not. And, the basic idea is treatment versus control, before versus after. Do we see more pixels that are tree covered because of in places that were randomly assigned to have PES? So here's, the bottom line results of this study, which is over these 2 years, 9% of the forest that existed in the control villages was gone. So that's a very high rate of deforestation. So, 5% a year in 20 years, there's not going to be any forest left in Western Uganda, and this is important for biodiversity. It's where chimpanzees live, and it's important for carbon. In the treatment villages, the rate of deforestation was halved. So it wasn't zero. It was a voluntary program. Some people said no, thank you. They didn't want to sign up, but it was a substantial drop in deforestation. And this was equivalent to, in each of the treatment villages, there's an extra 5.5 hectares of trees due to the program. Okay, so one thing we also do in the study, which is you can do when you're sort of thinking about carbon effects of programs, which is to think about the costs per averted ton of CO2, and then compare that across programs and compare that to the social cost of carbon that I'm sure will be covered in a future class. And so in our case, we need to convert the hectares of tree cover to how much CO2 was kept in the ground. It wasn't kept in the ground permanently, but temporarily, and then compare that, sort of put a social value on that. And when we do that exercise, we come up with a benefit to cost ratio of 14.8. So this is, seems highly cost effective, taking, but probably considered a low social cost of carbon that the US government was using at this time. So just to put a little bit more detail on that, the steps are to go from 5.5 hectares per village to 3,000 metric tons of delayed CO2. Where do we get that from? Geographers have estimated the carbon content of forests in different parts of the world. Then, how do we think about those delayed CO2? What's the social value? We have to make some assumptions about what's going to happen after the program ends. It turns out what happens after the program ends is people go back to their normal rate of deforestation. So they never kind of catch up. And so basically whatever was paused for 2 years is sort of a permanent benefit. And then we can think about the program costs in the same unit, and it's much lower. So what I put here, what we published in the science paper, which was a conservative cost benefit or benefit cost of 2.4. We've since looked at what happened after the program ended, as has another researcher who used Landsat data to do the same thing, and kind of both with this result that deforestation was at the typical rate afterwards, and so that gives us the higher benefit to cost ratio. So besides thinking about this relative to the social cost of carbon, maybe a more practical, you can debate till you're blue in the face about the social cost of carbon, but we can also just think about other options to address climate change. And if you do the same exercise, many US government carbon policies with domestically have a benefit cost ratio less than 1, or at least have a benefit cost ratio much less than this 14.8, which is just another way of saying that this is globally cost effective. And so, kind of, I think one of the points I try to make a lot, Rachel Glenister and I recently wrote a Journal of Economic Perspectives paper on this, that, wealthier countries should probably be shouldering the burden of paying to mitigate climate change, but some of the cheapest opportunities might be in low and middle income countries. And so there's sort of an arbitrage opportunity to take advantage of those inexpensive ways to mitigate climate change, so we can do more climate change mitigation, within the budget that Norway or the US or Spain has allocated to climate change mitigation. Okay, so let me come back to this point of, does PES, is it about poverty reduction? Does it reduce poverty? And so I think this is important because, if you follow debates about what's happening for climate change mitigation, many governments like the UK government or the World Bank are trying to fund mitigation in low and middle income countries, but they sometimes classify that as development aid. So I think it's an important point to make that, that's the wrong way to think about it. And so, you often hear that there's a win-win of PES or kind of conservation in developing countries, that it's both helping the environment and reducing poverty. That can be true, but it's important not to double count. And so what do I mean by that? I mean that some of the payment is compensating people for their cost to comply. It's compensating people because they couldn't make as much money selling charcoal. They needed that money to feed their families, send their kids to school. So it's not making them richer than they were without PES. It's just offsetting that lost income. And so that money is not improving their economic well-being relative to not having PES. It's just ensuring that they're not worse off. And then the real benefit was we got them to conserve. So in what way is it accurate to call it a win-win? I think it's you really want to think about it as not increasing poverty, unlike the alternative of a ban or a tax. And then there's going to be some incidental poverty reduction. And when I say incidental, I mean that there are going to be cases where, from a conservation point of view, you'd want to just pay enough so that someone was indifferent. It's hard to do, but so we're often going to overpay people, and that overpayment for the conservation goal is making them better off financially. We're not going to underpay them, hopefully, because it's voluntary. So if we were not paying them enough to offset their opportunity costs, they should just say no thank you to PES. And so there is some, kind of like a direct trade-off that the more successful the PES program is at environmental conservation, the less it's going to be beneficial in terms of increasing economic well-being. So it's kind of an inherent trade-off. In the cases where the payments were completely inframarginal, people were going to conserve anyway, that's when they're actually getting more money in their pockets and being better off economically. But it's also the case where we didn't have any additional forest cover. Okay, so let me just kind of lay that out a little bit more detail. If you can think about conceptually, not in a literal sense of observing this, a payment across people or within a person is partly an amount that's compensating them for their cost of changing their behavior. It's what's making them willing to actually participate in this or comply with the program requirements. And then the remaining amount is a pure transfer. That's the part that's equivalent to a cash drop that's making them better off financially. Then that pure transfer or inframarginal payment is the component that's helping raise their income, relative to if there had been no policy in place. So, you could think about a program that pays a participant some amount M if she undertakes the required behavior, like keeping her forest intact. And then she's going to incur some cost C to undertake that behavior. That cost could be negative, in the cases where those would be cases where she was going to conserve anyway. But our worry, or, the reason we have policy intervention is that in many cases that cost is positive, and that's why people weren't doing it. Those costs could be monetary outlays, it could be time costs, it could be opportunity costs to comply. So then you can think about someone who's in the program is falling into one of three categories. If the cost to comply is larger than the payment that's being offered, they're not going to participate. They're not going to comply with the program requirements. If the cost is less than zero, that's the case where they're going to undertake the behavior regardless. So that's a case where so the first case, there's no environmental benefit because they don't opt into the program. The second one is there's no environmental benefit because they were going to do the conservation anyway. And the full payment of M is a transfer to them. And then there are intermediate cases where, these are the cases where the payment is enough to offset their positive costs of conservation. So these are the cases where we get some environmental benefit. And then, here the pure transfer would be the wedge. If M is the amount between M and C is going to be the amount that makes them better off. Okay, so if you could observe a policymaker's only goal was conservation, and they could see everybody's costs, you would set M equal to C. Everybody would comply, and there'd be no pure transfers. In practice, participants differ in their compliance cases, and you can't observe it. And Kelsey Jack has done some work on trying to use auctions to get people's individual prices and be able to, basically have first degree price discrimination. Or second degree price discrimination, but that's, challenging to do in all cases. So thus M is going to be greater than C for some participants who comply. Okay, so, kind of map it, I'm going to kind of revisit this study in Uganda and try to map these points to see what happens in the data. And you have to, how do we measure compliance costs? It turns out the most financially important use of reason to deforest was to sell trees. And so we have in our data the foregone income from selling trees. So, this is where randomized control trials are useful. Having a control group is useful now for another reason, which is I can use the data in the control group from selling trees. They didn't have PES, so I have a measure for just the control group of how many trees they sold absent PES. I don't know that for the treatment group because I only observe them with PES. But this is one of the uses of machine learning in development and other fields right now. Is to try to predict the counterfactual. So we can use our rich baseline variables, which we have in the treatment and control group. In the control group, I know how much income they got from deforesting. And then I can use lasso, or you could use a different machine learning technique, and you can have a predicted value. And so now you can port that predicted value over to the treatment group. So now for everybody in the study, I have a predicted income from selling trees. And so now for the treatment group, that's my measure of C. It's how much money they lost by complying. Okay, and then for the economic gain from participation, how much were people's poverty reduced? Did they become better off? We have different survey measures we can use, but we have a self-assessment of economic well-being as sort of a holistic measure. Okay, so and here's kind of, I can probably, this is the main figure I want to show you, which is here are the folks on the left who have a low predicted forest income. So both in the control group and treatment group, these are the folks who we predict if they didn't have PES, they wouldn't have been selling a lot of trees. They wouldn't have been making a lot of income off of their forests. And the outcome here is this measure of economic well-being. And so you could see in this group on the left, they are actually economically better off because of PES. Like, these are the folks who probably weren't going to deforest anyway. They weren't going to lose money by participating by shifting to conservation. And so those are the folks where the transfer, the PES payment when they comply is a pure transfer, and they're better off economically. The folks on the right, the ones who absent PES were going to deforest, make a lot of money from selling trees. Those are the folks on the right are the ones where we probably got additional tree cover, but we don't see any benefit to the treatment group economically. And then, who gets the pure transfers? It's not part of the design of PES in most cases. This is sort of accidental or incidental. It's who happens to have the low cost to comply, who happens to be the people who weren't going to deforest anyway, weren't going to make a lot of money from selling trees. It's highly unlikely it was the exact same people you would prioritize in a poverty reduction program, right? If you have two different goals, you're going to target different people. And so, and it depends on whether it's poor people who have the low cost to comply. In this case, it turns out that's true. At least everybody's poor in this setting, but the relatively poorer people are the ones who got more of the pure transfers in this case. This is one proxy for poverty, which is having fewer than 8 years of education. And this is what their income from income from cutting trees was. And you can see it's the richer people who make more money from selling trees. It's partly because they often have more income, and they have chainsaws. They're closer to roads and markets, etc. They're so what is the upshot of this is that we're probably getting more of the additional tree cover from the relatively richer people in the sample, and we're getting more pure transfers to the relatively poorer people. And we could see that in this table. So the first column is just showing you that the richer and poorer, they were as likely to comply with the PES. So they were as likely to receive payments from the program. What column 2 is showing you is what was the forest income in the last year. So this is at our endline survey. So how much did you get in forest income? And what is this treated coefficient? This treated coefficient is the main effect. So it's this omitted group of greater than 8 years. And you could see for the treated group, there was a reduction in forest income. Whereas for the poorer households, if you add these two up, there's basically no reduction in forest income. And what column 3 shows you is that the flip side of that, which is it's the relatively poorer people who were the less educated people who saw the economic benefits of participating in PES. Okay, let me just do a recap on PES and say, if the societal benefits of conservation exceed the private costs, it's efficient to conserve. That's societal benefits within a country. And if we can get infusions of money from outside, we really want to think societal benefits from the whole globe. How do we do that? One of the tenet where economic logic is helpful is we want to put a price on degradation, and that's going to discourage it. And what's the point here is that there are many ways to have a price. It could be a fine, it could be a tax, but it can also be a reward. So we can keep that market-based approach, like a cap and trade logic, or and prices, we can decouple that from the decision of who should bear that cost. And PES is valuable when the person you want to change, whose behavior you want to change, you don't want them to bear the cost, for example, because they're poor. There are other alternatives to PES, I should say. You could subsidize an alternative activity, maybe some other building materials so people don't use trees, or other fuel source so people aren't using trees for fuel. And then, the last part of what I was talking about is that PES is not development aid. It only raises the income if we're sort of overpaying for the conservation goal. And so I've just sort of talked about two of the core ideas, some pretty basic research on this. There are plenty of additional research questions. I think it's a ripe area to do research on. How to target the program to increase additionality is really the holy grail. I mentioned Kelsey's work on auctions. There are other ways to try to how to target it to the most ecologically important areas, but also people who wouldn't conserve absent payment. I think these questions of leakage and general equilibrium effects are important. And then there are many contract design questions of how can you improve the efficacy, maybe think about balancing or even kind of squeezing more economic anti-poverty benefits out of this program, with some contract design or targeting issues. So let me spend maybe 1 minute just introducing another topic, which is about how poverty and economic development affect conservation levels. And here, I don't know that there's anything special about conservation versus just environmental protection in general. And I think I have a sort of I did a recent review article on this where I was trying to come up with some general laws about when is economic development going to help the environment versus hurt the environment. And I think my takeaway from reviewing a lot of literature is that it's mostly anything goes. And I think that makes it hard to predict whether economic development is going to help or hurt the environment. It also just reinforces that we can't bank on magical thinking of a win-win. Many times economic development is going to hurt the environment, and so policymakers are going to have to think about a trade-off. I think you could think about this with an increase in household income. There are many times that increase in household income is going to create degradation. We're going to purchase more things or consume more meat, but on the flip side, it might also mean people are willing to sacrifice to protect the environment. So let me stop there and turn over to the Q&A and Erin. So thanks a lot.
Okay, great. Professor Jayachandran, Professor Olken, for your presentation. So now we'll start with the Q&A. Thank you for everyone who has put questions in the Q&A box. There is an option that you can upvote other people's questions if you think that it's interesting. So please do so at this time. So Aaron can field the questions. Aaron Berman is a PhD student at MIT, and so he'll be helping answer all these really great questions. Just to reiterate one more time, if you missed anything in the lectures or you want to review the notes or papers, they are accessible online on the IGC BRED website. And so I'll turn over to Aaron, who will be selecting questions both from our panelists today as well as from the Q&A box. So if you still have questions, there's a lot going on, but you have a few more minutes to submit, and he'll try his best to get to all the questions possible.
Great. Yes, so thank you so much, Allegra, for the introduction, and thank you, Ben and Seema, as well, for the really informative lecture. So as Allegra mentioned, I'm a PhD student in the economics department at MIT, and I'll be trying to field some of your excellent questions. To start, I thought it might be useful. There have been a stream of really great questions throughout the lectures. I wanted to just quickly recap some of the major themes that emerged from some of these questions, and hopefully that addresses lingering issues that might be on your mind from the lecture. And then I'll go through and try to address any other questions you may have. There's a lot of questions, so I'll do my best to cover the biggest ones and ones that might that other people might be wondering as well. But apologies in advance if I'm not able to answer every single one. So one theme that seemed to emerge a lot from some of the questions during the lecture is, what exactly do we learn from Professor Olken's paper on the Brazilian Amazon, and specifically, what do we learn from a paper that is doing a regression discontinuity design? So as Professor Olken mentioned, the key thought exercise in this kind of paper is to zoom in really close to the border, and in order to understand what is the effect of being in Brazil per se, as opposed to in Bolivia or another Amazonian country outside of Brazil. And so what you learn from the regression that you run in that kind of regression discontinuity setting is very localized to the pixels of land that are within the bandwidth that the authors have chosen. So that's kind of an inherent limitation in doing this kind of analysis. But one question that came up very early, and I think this was by Casey, is does this mean that the effect is uniform, or is this assuming that the effect is uniform elsewhere in Brazil, inside closer inside the border? And so this is kind of an active area, and this is of research, not just in development and in environmental economics, but in applied econometrics more generally, of how do you extrapolate effects that you estimate from an RD to places that are away from the cutoff. And the answer is there's many different approaches that have been proposed, but I will refer you to section 2 and section 6 of the paper that Professor Olken mentioned, because they do precisely try to think about, are there ways we can extrapolate from this effect to think about counterfactual policies that the Brazilian government might implement, and what the deforestation effects of those might be. In order to do that, you do have to impose some additional assumptions about the relationship between deforestation rates and other observable characteristics of the land. So for example, their distance to markets, their distance to urban centers, or some geographic features of the land, and then estimate some relationship between those features and deforestation rates. So there's a lot of assumptions kind of baked into this exercise, but there are ways that researchers are starting to extrapolate the estimated effects from a regression discontinuity design. One other question that came up in relation to this study, which I'll also cover, is are there other forces that might be at play in addition to just the Brazilian government's conservation policy that are influencing deforestation rates? So almost certainly there are also agricultural policies or agricultural incentives that are at play that are influencing deforestation rates. So to kind of reiterate what the key assumption or the key thought exercise that underlies the regression discontinuity is that the only difference between pixels that are just on the Brazilian side versus just on the Bolivian side is the national policy regime. And therefore what's being estimated is kind of the net effect of being on the Brazilian side of the border, taking into account that there's lots of policies, not just any single one that Brazil is implementing, that are influencing deforestation rates. That being said, another key assumption, which the authors have some discussion of in this paper, is that the land being examined in the study is relatively integrated across the Bolivian and Brazilian side. So you have some Brazilians who are owning land in Bolivia and vice versa. And this is important when thinking about the market access of people who might be deforesting in those regions, that they could be selling on the Bolivian side or the Brazilian side. And I'll refer you back to the paper for further discussion of that integration on these parcels. A final kind of theme that I wanted to cover is related to Professor Jayachandran's paper on payments for ecosystem services. And there were a lot of really great questions about the design and kind of various considerations related to PES. So I'm also happy to field any additional ones that come up. But one question, which is, I think, an underappreciated point that came up in some of the Q&A is what happens when someone doesn't comply with the PES program? So we give them the money, and is there anything forcing these landowners to actually conserve those trees or not cut those trees down? So this is, I think, underappreciated, that most PES programs in practice actually don't have penalties built in for noncompliance, or that penalizing noncompliance is actually quite hard to do in practice. And so that's why I think, and I think the authors think as well, that it's a useful, just empirical benchmark to see under a contract where there are no explicit penalties for noncompliance, what are the actual compliance rates? And that gives you some estimate of, to what extent did this policy work? Did these programs work? And, for future programs that might be implemented, do we need to kind of more narrowly tailor the program or introduce additional design elements to prevent or disincentivize noncompliance? And actually, in the context, at least, that Professor Jayachandran was talking about, the compliance seems to be quite good. But we wouldn't have known that ex ante without kind of quantifying that empirically, and that's why it was useful for doing so. One last item, and then I'll stop talking and I'll turn to some of your newer questions. Is related to this. Some questions came up about, well, why would what are some of the costs of noncompliance that Dr. Jayachandran was talking about? So in addition to this opportunity cost or this foregone income, what are some of the other costs that might that households might be entailed in complying with the program? So for many households, there are specific costs of enrollment. So dealing with perhaps complicated terms of the agreement, having to actually physically enroll. These are kind of generally referred to as hassle costs of enrollment. And so those are kind of like the physical material costs of actually having to engage in some kind of contract. But one other point, and I'll also take this as an opportunity to plug another one of Professor Jayachandran's papers, which she didn't have time to mention in her lecture today, is also thinking about potential liquidity constraints or credit constraints in the settings that PES programs are often implemented in. So, for example, if households need to cover a particularly large or lumpy expense, such as like a medical expense or a large investment that they need to make, cutting down trees might actually be a useful way for them of covering that large expense. And in a setting where they don't have other means for borrowing money, in credit markets. And the stream of payments that households receive in a PES contract might be small, or they might be, the individual payments might be small and spaced out over time. And so these liquidity constraints are actually really important to think about when designing the PES program, because even if the overall total value of the PES payments is larger than their costs of compliance, you might run into some of these liquidity constraints, and that might decrease or compliance rates or increase default on the PES contract if those aren't taken into account. So I'll now turn to the Q&A box and see if there are any additional questions. I tried to do my best to just summarize some of the main themes that came up during the lecture. So just give me 1 second to refresh this. So yeah, so some of the questions that have come up are also related to related research on PES in other contexts. I'm not aware. So this is in response to Matt's question. I'm not aware of PES per se for in the context of small and medium firms, but I guess in the context that Professor Jayachandran was discussing, these are kind of private forest owners. So these are individual families who have ownership over particular parcels of forest land. But it would be interesting to think about how firms might engage with these kinds of contracts as well. Yes, so I guess in response to Pedro's question, yes, I think the idea is that the amount paid to families or agents who are engaged in a PES contract on net should be higher than the cost or the foregone costs or the foregone income that they are not receiving by not deforesting. But then, of course, you also need to take into account some of these other opportunity costs, such as the hassle costs that I was mentioning. Yeah, so this is a question related to increasing appetite for land cover change. So one other point about PES contracts that I think is underappreciated is that landowners, the opportunity cost of deforestation or conservation changes over time. And so far throughout this lecture, it's kind of been a little bit abstracted from and assumed that opportunity cost is just kind of a fixed object. But if you think that landowners are integrated into into markets where commodity markets where the prices of agricultural commodities are changing over time, that opportunity cost term is also changing. And in practice today, we don't see that many PES contracts that are kind of flexibly accommodating landowners changing opportunity cost of conservation, but that's something that you think might be actually quite important, and it's definitely an avenue for important avenue or area for future research. Let's see. Let's see. I'll also, for the panelists who are here in the room, you can feel free to raise your hand and pose a question live if you'd like, if you have any. You don't need to limit yourself to the chat box.
Aaron, actually, maybe what I'll do is I will take one question I will ask them to talk because there are a few participants who've raised their hand. Is that all right?
Yeah, absolutely.
Okay, I'm going to call on Rudo Rubin, if you'd like to speak. Rudo, are you there? Okay, I'm going to move then to oh, you're there? Great.
Let's see. Can we ask them to unmute?
If not, we can move to
okay, yeah.
Yeah, let's move to Hina Oak. Hina, are you here? Okay, I'm going to move down for one more person and then you can take some. So let's take Emmanuel, or actually let's take Yucheng Kwan.
Yeah, thank you, Allegra. So I have two questions to Professor Olken. The first one is for his study on political cycles. So we know the politicians have the career concerns. So the career concern model gives out the prediction that the regions with the politicians successful in the re-election can perform much better relative to those regions changing the politicians during the election year. So it kind of did he observe such phenomenon in the deforestation? So if not, I'm thinking are these strategy with the vote rate as running variable might be able to give an estimate on it. And the second question is about the page 16 of the Professor Olken's slides. So this slide shows the time trend of the RDS coefficient. Or further, we can say it is an effect of Brazilian policies on deforestation. So do we have any existing explanations on why the policy seems ineffective during 2006 to 2011? It looks like the coefficient is totally statistically insignificant and close to zero. And could the deforestation or some more possibly the political cycles can explain it? Thank you.
So I'm actually still here. So I don't know if maybe I'll take a question or two, and then Aaron, you can take some more if that works.
Yeah,
so,
nice to speak.
if you want to chime in, Ben, feel free.
Yeah, sure. So thanks for the questions, Yu Cheng. So and thanks, Aaron, for all the explanations, both in the Q&A and in the that you gave. It was fantastic. Good question about incumbents. We don't explore that differentially. It'd be an interesting question to look at. I think that the key political idea, though, is it's looking at, about political cycles is looking forward to the next election. So it's not totally obvious to me you would see differential responses for incumbents versus new people, but although I guess maybe you would actually take it back. Actually, I think you'd be an interesting question, because you might say, well, the incumbents are the ones who are able to control the policy and look moving forward. So that would be interesting. We haven't looked at that. So it's a good question. I guess you could also think about whether there were similarities between parties. So not totally obvious, but it's an interesting question. And then your other question was about sort of what's going on in Brazil and why do we think it kind of falls in the middle period. We go through that. I just refer you to the paper. We go through in the paper in a lot of detail all the changes in Brazilian policies that were happening during this period. But there was a lot of stuff that's going on. So actually, it's not at all surprising that you see that in the data.
I see. Thank you, Professor Olken. Nice to see you this time.
Great. So I see there's a question that's come up about spillover effects of PES programs. So at least in the context of the paper that we saw during the lecture, this is something that can actually be examined explicitly of using the satellite data that the authors have access to. You can say, do we see deforestation rates increase in areas that are physically very close to the treatment areas where the PES program was introduced? The authors find in this setting that those spillover effects, or what Professor Jayachandran referred to as leakage, were not present. And underlying that is kind of the assumption that the demand for timber is, there's some elasticity of the demand for timber. So it's not that the same amount of timber is going to be extracted no matter what, and it's just a matter of it's being displaced somewhere to somewhere else. The results of Professor Jayachandran's study seem to confirm that there is actually some aggregate reductions in deforestation that can be obtained from these kinds of programs. There was another question that I saw. This might have come up a little bit earlier regarding the design of PES programs. This seems to be something that's stirring up a lot of interest. So there's a lot of really great questions that have come up about a lot of really important logistical details and design details related to PES programs. So the question was kind of, how do you prevent gaming? So for example, if landowners know that there's going to be this reward for planting seeds or for conserving trees, how do you design the policy or the program to prevent that kind of gaming behavior? So I think that that's actually a really active area of research right now, and it's not just in PES programs in developing countries. So this is a concern that's come up in payments for ecosystem services in the US, for example, where the government is trying to get agricultural landowners to retire agricultural land. And so researchers in various contexts have examined precisely this kind of behavior. But I will say that this is something that that seems to be an active area of research. In some contexts, this kind of gaming behavior appears not to be so much of a concern empirically, but it is something that that researchers are still kind of experimenting with and trying to understand what features of a PES contract might optimally address that kind of behavior. Let's see. apologies, I'm just reading through these questions in real time right now and trying to digest them. Yes, so there's a question that just came up, which I think is actually exactly the kind of key tension. This is from Khusro Mir. So this is exactly the kind of key tension or the trade-off that Professor Jayachandran was referring to in her lecture, which is that exactly this point, that if a policymaker or a planner has an environmental goal in mind, i.e., we want to avert this amount of deforestation, or we want to, reforest this particular amount, and they also have the objective of minimizing cost, then there is this trade-off, you want to pay exactly the amount you want to pay to avoid that, and no more. And that goal is in tension with an alternative policy goal, which is to alleviate poverty or to provide fiscal transfers to households who are poor. And in order to achieve the latter goal, you need to sacrifice some of the former goal, i.e., you need to spend a little bit more than you would otherwise do in order to just incentivize the environmental behavior of interest. So I think you've articulated precisely the trade-off that Professor Jayachandran is illuminating in her lecture and in her in the papers referenced.
Yeah, and Aaron, let me jump in just to add to that, and also echo the thanks for doing this. Yeah, so I think one point to clarify is that, in some PES programs or conditional cash transfer programs, like, there's actually not really strong monitoring and enforcement, and so some payments are going to people who didn't comply. In the case of the PES program in Uganda, there was monitoring and enforcement in the sense that you didn't get the payment at the beginning. You only got the payment if the NGO found that you had kept your forest intact. And so in that sense, it is paying people only if they fulfill the contract terms. And so, that it was like well executed in that sense. But, even in those contexts, you can overpay. You're not paying someone who didn't comply. So it's just about asymmetric information. Some of those, so a buyer of ecosystem services says, okay, I want to pay people if they keep their forest intact. That happened. But what you can't observe, this is the challenge, is that not everybody you pay, not everybody who complied would have deforested. And so, and this is a very analogous, or it's exact same problem that happens in conditional cash transfers, for paying families if they send their kids to school. You can observe if they send their kids to school and you pay them, but if 9 out of 10 of them were going to send their kids to school anyway, you're paying 9 people who you didn't have a change in education and 1 person who did have a change in education. And so that's the challenge of, is that a cost-effective way to increase education? It depends on whether paying 10 people to get 1 person to extra person to send their child to school is cost-effective.
Yeah, thank you, Seema, for adding that. Let's see, Allegra, do you want to, if there are other people who maybe have their hands raised, and maybe we can call in another live question?
Yeah, that sounds great. We'll take one last question from Juliette Cacheteau. I'm going to allow you to talk. Let me see if it works.
Thank
Juliette.
you.
Okay, you're there.
Thank you. So I asked a question in the chat about the potential behavioral effects that there could be by offering the treatment to people, especially in the case of the PES. So could it be that offering a reward for conserving trees raises people's private valuations, and that would be a feature in the model? So people have a private valuation of conserving the trees, and now they would be more willing to conserve it regardless of whether they would receive a particular amount or not. Thank you.
Yeah, let me try to tackle that, see if I understood it. I think you were saying that just after, you can think of it as like period 1, people get PES and they were going to deforest, now they got paid. And then does that change their preferences or their economic situation, so that when you take the payments away, they're more or less likely to deforest. And I think you were suggesting that maybe it's actually making them more willing to conserve. So I think in some contexts with PES, it's like an experience good where you didn't want to do something, you thought it was going to be really hard, and you learn that it's not as hard as you thought, and so you continue after the payment. So you should think of things like people, use this. Pascaline Dupont has work on bed nets where you subsidize it. People realize it's kind of better than they thought, and then you could take away the payments, the subsidies, and people continue to do that. So you could think of the analogous thing happening here. In this context in Uganda, people were really losing money if they didn't cut. So it's probably not changing their preferences in that way. But you could imagine, like, here's the scenario where it could have permanent effects. So people would cut trees as a source of emergency cash, to pay a hospital bill. And you could imagine when you were under PES, you realize, okay, now it's really costly to use trees because I'm going to lose these payments. Let me pay the fixed costs to, develop a relationship with the bank, get lending relationship. And now, once you have that lending relationship, once you paid that fixed cost, the next time, even without PES, that you need an emergency expense, you could go get a loan, rather than cut trees. So that's not a preferences story or a behavioral story. That's just like a pure neoclassical story where, there might be some fixed costs or returns to experience and things like that, such that you could have permanent benefits from a temporary program.
And I might add, one thing you might do if you were interested in precisely this kind of question about does the program change people's kind of inherent valuation or desire to conserve per se, is you might imagine some other kind of evaluation where in one treatment group you give the PES program, and in another treatment group you only give some kind of information or some other kind of campaign that's specifically just telling people that conserving is important, and see what the differences are in deforestation rates among them. And I'm not aware of any study that's kind of thinking about just this more behaviorally targeted intervention vis-a-vis the effective PES programs, but that might be interesting to look at.
Yeah, and we're over time, but I'm going to use this. I have like a hobby horse that I'm going to mention, which is, I think when I present my work on paying people, many people say, that doesn't seem sustainable. Have you thought about trying to just like convince people to care about the environment? I think that's very ethically tricky, because a lot of the benefit, it's a global externality. So if I change poor people's preferences, so they're internalizing the cost of their behavior to me, who's, much richer than a Ugandan farmer, like I'm asking, that they're what does it mean to internalize the preference? They're saying, okay, it's fine, I'll skip a meal, because I want to protect the forest. I want to help Seema and other rich people have less climate change. Like, I don't feel ethically comfortable doing that. So I think, when there are global externalities and we're thinking about poor versus rich, I think it's like there's a very kumbaya kind of, a rah-rah way of thinking about making people care about the environment. I think when we think about global inequalities in income and there being economic trade-offs when protecting the environment, you want to, be cautious about promoting environmental protection per se among the poor. Okay, I'm going to drop off, but thanks everyone for participating.
Let me say the same thing. Thank you, everyone. It was a delight to talk to you about these issues, and thanks again to Erin for answering. She does a great job answering the questions, and to Allegra and the whole IGC team for helping organize it.
Thank you so much.
Okay, thank you. And just a reminder for those still on the line, the lectures are recorded and they're posted on the BRED IGC website at theigc.org. The slides will be posted, and if you have any additional information, you can email or any additional questions, you can email igcresearch@thelsc.ac.uk. Thank you all again, and thank you, Erin, for the Q&A as well, and we'll be ending the webinar now.
Of course, and I think we wanted to also mention that the next week's lecture is going to be at the same time and place. It's going to be by Professor Esther Duflo on climate adaptation. So hopefully you'll all be able to attend that one as well.
Thank you.
Thank you so much.
Thank you.
Thank you.
Thank you.